Hey everybody, welcome to our last installment all about the different types of elements on the periodic table. So as you probably saw in class already, just by looking at the elements, we can break them down into a bunch of different categories, and not just with pure substances or compounds, but the elements themselves. We can categorize them based on their physical and chemical properties. And what you saw in that lab that we recently did is that it's pretty easy to look at them and to differentiate between those different types of elements. So that's what we're going to review in this video, are just some of the basic characteristics of the four very basic types of elements, and then we'll progress into them further and actually further categorize those different elements. So you probably already know that there are four very basic types of elements. So there are metals, you have nonmetals, you have your metalloids, and you also have your noble gases. So what we're going to do first is actually talk about the different characteristics of each of these types of elements. And then I want you to grab some highlighters, grab some colored pencils or markers, or you can just circle them all, however you want to do it. We're going to look at a periodic table and then further differentiate between those regions in your notes. So let's go ahead and get started. So the first category of elements that we're going to look at are your metals. And of course, a great example of a metal that you're very familiar with on the periodic table is copper. And copper is what you see on the screen right there. And I also have a piece of copper here as well. And another one that you might have looked at in that lab was nickel. So it actually has the symbol on that right there. So this is the element nickel. Similarities between copper and nickel and all of the metals on the periodic table. Your metals all have a metallic luster, and a metallic luster is a fancy way of saying that they're shiny. Both of these are very shiny metals, as you can see. Metals are also really good conductors of heat and electricity. That's why this image on the screen has copper that's pulled into a wire. And that's because all of your wires that charge your phone, that charge your iPad, that whatever for electricity, copper allows for a flow of electrons to go through that very easily. So they're very good conductors of heat and electricity. And that's also why in the beginning of the year, when we did the lab safety unit, you had to hold the copper with the tongs, because even though you're only heating this part right here, this end of the copper also gets hot because it is a great conductor of heat. They're also very ductile, and ductile means you can pull them into wires. So if I wanted to, I could pull this and stretch this really, really thin, so I had the wires that were shown down below. And the word we use for that is ductile. Ductile means pulled into wires. And lastly, metals are very malleable. And malleable means that they have the ability to be hammered, or that they're very bendy. So like this copper right here is very malleable. I could take this and I can alter the shape very easily. This nickel is a little bit harder to do so, but it is in fact also malleable. I can take this and manipulate the shape for reasons we'll talk about later on in the course. These are very four basic characteristics about all types of metals. Now we could break metals down into further categories, but let's just go ahead and talk about the other three basic types of elements first. Let's go ahead and distinguish also where are the elements on the periodic table. So grab one colored pencil, doesn't matter, one marker, and let's go ahead and identify their location. So here's a really nice image of the periodic table that I always like to show. And excuse the fact that this is on some selling website. I don't know what they're trying to sell. I guess pictures of the periodic table, but I do like this one, not only because it's not colored in any way, but also it's 100% updated. So within the past, I would say maybe 3 to 5 years, I don't remember exactly how long ago it was, but these elements down here started to get names for them. And it's very difficult to find periodic tables with all of the updated information. So that's why I wanted to use this periodic table. And I can't copy and paste it because I use the app Screencastify. And the way that it works is that I can't really highlight unless I'm in a browser, and There's a lot of stuff that goes into these videos. So anyway, let's go ahead and identify where those metals are located on the periodic table. And whether you're highlighting, coloring, or if you're just circling, it doesn't matter. Pick your favorite color, pick your favorite pattern, whatever, because there are a lot of metals on the periodic table. What I want to do first, though, is to draw a separation part of the periodic table, which I think is very important to know where it's located. And we call that the staircase. So I'm actually going to start on the outside of boron right here. And I'm literally just going to draw a staircase going down like this. And I think it's important to just identify where that staircase is, because this is going to help us to remember where each of these types of elements are located. So you might remember, if we talked about this in class already, that this kind of helps us to separate the two very basic types of elements on the periodic table. So again, we call this the staircase right here. So this is the staircase. Not entirely important or that you need to know it, but it is good to know where that's located. Like I said, pick your favorite color. Not my favorite, but I'm going to pick like this chartreuse color. And let's make a key. So I'm just going to color a little section here. And I'm just going to label this as metals. And let's go ahead and just identify where these are located. So metals are most of the periodic table. And in fact, they are going to take up this whole first section right here. So you can either color these in, you can outline them like I'm doing, whatever you want to do, just as long as you know where the metals are located. That's one section of the metals. You also have this whole center section right here. And all of these sections have different names that we'll talk about later in the year. But all of these elements are also metals. So that's like where we saw our copper, and that's also where we saw our nickel in that center region. We also have some elements over on the left-hand side of the staircase. So it's not all of them, but most of them are metals. So it's all of these elements here. And again, they kind of staircase down with the exception of aluminum there towards the top. Those are also metals. And we also have more. So these elements down here towards the bottom, this whole entire region, also metals. And these have all of the properties that we listed before. So these are all malleable, they're all ductile, they're great conductors of heat and electricity, they're all shiny. And there are so many metals, as you can see. And what we'll do in a later video, or maybe in person, is we'll break these down into smaller categories, because not all metals are exactly the same or have the exact same properties. But the metals that we've talked about so far they all have those very basic properties. Like we said, shiny, malleable, ductile, great conductors of heat and electricity. Notice I didn't color in hydrogen. Hydrogen is not a metal. Hydrogen's like the lone wolf on the periodic table. It's the simplest element. It's the first element. And it kind of has properties all on its own. So it really doesn't fit in any particular category, which you're going to see. Let's go ahead and move on to the next part of the elements. The second classification of elements are your nonmetals. And an image that's up here on the screen is actually sulfur, which you also saw in that lab that we were doing around the room. And I have sulfur right here. So I think this is the exact same one that you were looking at. Very, very different from your metals. This one I do have to keep in a vial because, as you could see, it's in much smaller pieces. And this one also has a smell to it. So this smells like rotten eggs. If you go to a friend's house and you ask for a glass of water and it smells like eggs, it's kind of nasty. But that typically has sulfur compounds in it. Another one you also looked at was carbon. So here's a big piece of charcoal that you might use in a grill outside. But both of these are non-metal elements, and you can clearly see the different characteristics that the nonmetals have compared to the metals. And the one thing about the nonmetals that's interesting is that these exist in all states of matter. So your metals are typically all solids at room temperature, with a couple of exceptions. Mercury is a liquid at room temperature. Gallium has a very low melting point. But your nonmetals exist in all states of matter. And in fact, they have some of the highest boiling points and melting points, but they also have some of the lowest boiling points and melting points, which I think is kind of interesting. Nonmetals are also very brittle, so I am being careful with this piece of charcoal because this will break. Of course, if I were to drop this on the floor, this would break into a lot of different pieces. This sulfur as well is very brittle. It's already broken up into a lot of different pieces, whereas my metals are not going to break. These are the opposite of brittle. These are malleable, but these will break. They're also very poor conductors of heat and electricity. That's why you don't have carbon inside of your electronics and used in wires, is because this does not allow for electricity to flow through it very well, or heat. And lastly, I think the most obvious thing is that these rarely have a metallic luster. These are really not very shiny, very dull in appearance. We also say that they are very earthy in their appearance. Just opposite of shiny, very dull, very earthy. Let's go ahead and show you where the nonmetals are located on the periodic table. So grab a different colored pencil and let's do that. So let's color in your nonmetals. So I'm going to pick this like bright pink color right there. And I'm going to label that after because I don't want to lose the color. And again, the staircase is important because your metals are on one side of the staircase, on the left side, and your nonmetals are on the other side of the staircase. But there are also some elements that are right around the staircase that are actually a different type of element. So I'm going to go ahead and color just these ones right here, pretty small section. And we call those elements the nonmetals. So those are your nonmetals. So like we said, carbon and sulfur. These elements are very brittle, they're very earthy in appearance or very dull, not very good conductors of heat and electricity. Notice they're on the totally opposite end of the periodic table, on the right side of the staircase. And notice that we missed that whole section right around the staircase. So if your metals, for example, are very shiny, whereas your nonmetals are not very shiny, and if this other section is literally in between the metals and the nonmetals, what would that say about their luster? Well, they might be shiny. And that's what this whole entire section in between those metals and the nonmetals are, is they're kind of like a blend of both the metals and the nonmetals. We call those metalloids. Let's talk a little bit more about that section. So you might notice that we colored in those metals and we colored in those nonmetals, and we skipped a region in between. And we call those types of elements the metalloids. And the metalloids, because they're literally in between the metals and the nonmetals, they're going to have properties of both of those types of elements. And I always really like showing this element because I think it looks really cool. But this is silicon right here, and actually it's on the screen for you as well. So this is a pure substance element. And this is just silicon. And silicon is one of those elements that we didn't identify just yet. And that's because this is not a metal, and it's also not a nonmetal, but it has properties of both because literally it's in between those two areas. So this silicon is similar to a metal because it's, of course, it's very, very shiny. In real life, it's more of like this purplish, bluish, silver color. It's really, really pretty. And so that's what makes it similar to a metal, but it is like a non-metal because it's very brittle. So I have this in a larger container, which you also probably looked at in class, but these are broken into a lot of different pieces. If you were to take this and to hammer this down, this would not be malleable, but it would in fact break. So your metalloids have properties of both your metals and your non-metals, which I think is really cool, because you kind of have these like almost mineral type looks to them. So like I said, there's also silicon up there. Now, this is not a metalloid, but it's close to the metalloid region. I always like to show this off because I'm very proud of this, but this is a bismuth crystal that I have. And this is really, really cool. So this is in fact a metal, but this is how bismuth actually grows in real life. So it takes on this like cubic shape to it, and it's really iridescent. It's like a rainbow. Not exactly a metalloid, but it's really close to the metalloid region. So you can in fact consider bismuth a metalloid if you really wanted to. Look at the bottom, it's so cool, like so geometric and neat. But yeah, so this is a piece of bismuth that I bought because I like to buy these types of things, and I always like to show this off whenever I can. So there's my little piece of bismuth. Properties of your metalloids. So these are typically all solids at room temperature. Like we showed, silicon is a solid at room temperature, and all of your other metalloids typically are. Not as malleable as metals, but they are not as brittle as non-metals, so they're somewhere in between. So if I were to try to take this silicon and if I dropped it on the floor, it might not break. Definitely not going to break as easily as the carbon, but it's definitely not as strong as the nickel, let's say. So it's sandwiched somewhere in between these two. Not as brittle as the non-metal, but definitely not as malleable as the metal. Some have a metallic luster. So of course, silicon has a metallic luster. Not all metalloids will, because again, they have properties of both your metals and your non-metals because they're literally sandwiched in between the two. These are also semiconductors of heat and electricity. You might be familiar with the phrase Silicon Valley, and Silicon Valley is literally named after the element silicon, which they typically reference in terms of technological advances like computers and stuff. And the reason why it has that name is because they use the element silicon in a lot of semiconductors in your computer. So I'm filming this on a computer, you're watching this on an iPad or on a computer or even a phone. They typically have little silicon chips in them, which are used to allow electricity to flow in and out of the parts. And of course, like we said, these have properties of both your metals and your non-metals because they're literally in between. So let's take a second and color the metalloids on that periodic table in your notes. So even though it's pretty easy to see those elements that are there, let's just go ahead and I guess I'll color these in because you can still see underneath it. So I have that element, boron, silicon, of course, we said is a metalloid, germanium and arsenic. Actually do have a sample of antimony that you might remember seeing in the lab. It almost looked like glitter. So that also is shiny, but it's not very malleable or ductile because it's kind of like a dust. Tellurium. There's some controversy about polonium and astatine, only because we don't know enough about them yet to really categorize them one way or the other. We'll just categorize them as metalloids. And we'll also call tennessine a metalloid. Again, we really don't know, but, and we don't know because it's such a new element for chemistry we're not going to get into right now, but we'll just label it as that anyway. You won't have to know that far down, just the very basics on the periodic table. Now those metalloids, like we said, have properties of both metals and nonmetals. So silicon is shiny like a metal, but it is brittle like a nonmetal, which is interesting. And it makes sense because it's literally found right in between those elements. Last one, let's do the noble gases. The last type of element, which is all the way on the right-hand side of the periodic table, we call those the noble gases. And I don't have any samples of noble gases here because I didn't want to bring home one of these expensive tubes and have it potentially break. So not here, but we can just imagine what you saw in class. There's really only one characteristic that you need to know about the noble gases, and that's that the noble gases are generally unreactive. And the fancy word for unreactive that chemists sometimes use is that they are inert. So you might hear of these also called the inert gases. These elements will not react with anything. You cannot set them on fire. If you were to try to light a candle surrounded by argon, it wouldn't light. Nothing would happen. These are not reactive with anything. So they have a lot of practical uses. For example, you're probably familiar with helium typically being used in balloons. Neon is used in signs when you go to like a pizza place or something. And of course, the other three have their purposes as well. But the primary thing you need to know about these is that they are unreactive, they are inert. Let's just go ahead and color that last section. And then let's do the noble gases. So I'm going to pick orange for this one. And all of your noble gases are located in this last row. So I'm just going to highlight these here just because it's easier, I think. So helium all the way down through oganesson, those are our noble gases. And again, the only property about these that you need to know is that your noble gases are unreactive. And the fancy word for that is inert. These don't like to react with anything else. It takes a very extreme conditions for them to do so. So there are your very basic types of elements on the periodic table. I hope that helped. We'll go over the other types of elements probably in class, just because I think it would be easier to do it in class. The coloring is a lot on the screen. So we'll do the other part of that in class. Anyway, as always, if you have any questions, email me, stop by, let me know, and I will see you in the next video. Bye.